Are you curious about what containers and virtual machines are and what the big deal is? With all this buzz around the technology, it must be pretty important, right? Hello, my name is Sergio Garcia, DevOps Engineer at Clickit, and in this video I'll be talking about containers versus virtual machine, what they do, their difference, and how they compare to virtualization technologies. So let's get started. Why it's important to know the difference between container and VM and how this will make our lives easier? Containers or virtual machines are virtualization technologies that package computing environments containing various IT components and isolate them from the underlying system. However, these tools have separate strengths and weaknesses, making them suitable for different applications. By distinguishing between containers and virtual machines, you can deploy applications faster, streamline troubleshooting processes, allocate resources from efficiency, and maintain security in your systems. So, what are containers? Containers are used to package and isolate applications and their dependencies in a lightweight and portable environment. Since they carry the application code, system tools, and settings, containers allow applications to run smoothly in various computing environments, whether on a developer's laptop, in a traditional data center, or even in the cloud. What are virtual machines? Also known as VMs, are designed to provide hardware virtualization. Essentially, they're software-created computers that can simulate real computers with their own CPU, memory, storage, and operating system. Based on this, they can operate in isolated environments to maintain better organization and security. Differences between container versus VM. Now, let's get into the differences between container versus VM. I know they basically sound the same, but they have some very significant differences that make them favorable in different circumstances. Let's see how they compare in various aspects, how they work. Containers operates by bundling all resources related to an application, such as code, runtime, libraries, and configurations, into a container image that specifies all these components. The container runtime then uses the details within the image to allocate resources from the host OS, similar to assembling a Lego model using the image instructions. This ensures that each container has its own isolated space within the OS, allowing it to operate without interruption. VMs utilize an hypervisor which serves as a mediator between the physical hardware and the VMs. The hypervisor allocates the resources needed for each virtual machine, such as CPU, memory, and storage. The virtual machine itself is a software file that includes the virtual hardware configuration. This allows the VM to run programs and functions like a regular computer. Alright, let's unpack arguably one of the most important aspects on both of these technologies, the isolation capabilities. While they share similar to a certain extent, this is where things truly begin to diverge. First, let's take a look at containers. Although containers share the host kernel, they manage to stay completely isolated from each one using namespaces and groups. The rules are such that namespaces isolate processes and networks from each other, while container groups manage resources allocations and utilization. Containers share the host machine OS kernel. While this gives you considerably lower resources overhead than a virtual machine, you might be vulnerable to security threats if you don't provide your container with the proper security configurations. Now, let's compare virtual machines to the isolation provided by containers. One key factor to consider is that each virtual machine runs on its own dedicated operating system, acting as a barrier providing a stronger isolation level between different instances. This isolation is archived through the hypervisor, which manages access to physical resources and network interfaces. Although VMs offer better isolation in the regard, it comes at the cost of requiring more resources and longer boot up times. When I talk about portability, I don't mean physical transporting containers or virtual machines, that's not possible. I'm referring to how easily applications can be moved from one computer environment to another. Container boasts excellent portability thanks to their lightweight nature. This is because container images are only a few megabytes in size, containing just the application code and its dependencies, such as libraries. This makes containers ideal for various deployments methods like cloud deployments, where applications might need to transition between different platforms or infrastructures. However, the portability of containers does have limitations. For example, when running on Linux distributions, they might not function properly if specific libraries are missing in the environment. Because VMs run their own OS, they can be ported between different computers as long as the system hardware architecture is compatible. However, since VMs also require their own compatible guest OS, the larger gigabyte requirements contributes to their notorious stand-up slowness. Apart from that, porting VMs between different environments with different OS can be challenging as it requires configuration adjustments. By now, you probably understand the basics functionalities of these technologies and how they work, but this can be stepped up by using some tools. Both containers and virtual machines can be paired with tools to maximize their use. Let me recommend you some tools you could use for your containers. Container runtime engines can be used to create containers, execute them, and delete them. The most popular options for container runtime engines is Docker Engine because it comes with a lot of features. Next, let's have a look at such key features. Docker is compatible with different OS like Windows, Linux, and Mac OS, giving it the versatility to help developers target different environments. It gives users a friendly user experience with features like Docker files to define container images and the Docker CLI to manage containers with intuitive commands. There's a vast ecosystem of tools and integrations including public registries like Docker Hub, where you can get pre-built container images, and orchestration platforms like Kubernetes. Docker is an open source tool with a community contributing to its development and accessibility, making it available to a wide range of users without any licenses cost. Also, you can watch one of our previous videos about Docker use cases. And for VMs, the main tool used is Hypervisor. This tool manages resources allocation between virtual machines and provides isolation. Popular hypervisors include VMware, VirtualBox, and Hyper-V. Up to now, we have discussed the major differences between containers versus virtual machine. Let me know what you think of these differences by leaving a comment below. When to use containers? Now that we know more about containers and virtual machines, let's review where you should use them. Cloud-native applications are specially designed to take advantage to the scalability and elasticity on cloud environments. So containers, due to the lightweight and portable nature, will be great for deploying cloud-native applications. Developers can develop, deploy, and scale applications quickly and efficiently with containers. If you know enough about virtualization to have heard of containers and virtual machines, you're probably also heard of microservices. If not, well, the name is pretty self-explanatory. The microservice architecture breaks down an application into smaller services. Containers are ideal for packaging these microservices because each service can be developed and deployed in separate containers, hosting the microservice along with its dependencies. Stateless applications. Seeing as these types of applications don't maintain any data on their own and rely on external storage, containers are a great fit on this. Due to simple management, easy scaling, and portability, stateless applications can thrive within containers. Since containers are ephemeral and can be recreated easily, you don't have to worry about data loss when a container restarts. Now that we've seen where containers can be used, let's look at virtual machines applications. When to use VM legacy applications? Legacy applications are older programs that were designed for specific operating systems. The common issue faced by people looking to adopt legacy systems is that modern systems rarely support them. You can get around this by using a VM, which allows you to install the older OS within the VM and run the legacy applications there. Monolithic workloads. These are programs built as a single indivisible unit. They can be difficult to deploy and scale because of their complex dependencies. VMs can be a solution for this in the sense that they provide a way to encapsulate this application along with the associated dependencies, making it easier to manage and scale them as you go. workloads with high CPU or memory demands. Workloads like scientific computing, 3D rendering, and machine learning need a lot of computing resources like CPU and memory. By using VMs, you can set aside specific amounts of processing power and memory for each virtual machine. This can help ensure that these resource-intensive applications receive the resources they need without affecting the rest of the system. To reiterate what we discussed, although VMs and containers are both highly competent virtualization tools, they offer distinct advantages that makes them suitable for different scenarios. Containers excel in portability, speed, and provide tools like Docker for swift operations, while VMs prioritize file security through isolation. We hope this video has been useful. If you guys have any topics that you want us to cover or any thoughts on the video, leave a comment below. We hope to catch you all in our next tech video. Don't forget to subscribe to our channel and watch our other content on DevOps and software development. Until next time, happy coding!